In this video, we're going to look at why we are able to cross-simplify when we are multiplying fractions. Let's start out by looking at a multiplication problem. 4/6 times 8 over 20. If we were just doing traditional operations, we would do 4 times 8 for the numerator and 6 times 20 for the denominator. And then we would have to multiply those out and then do a whole bunch of simplification. Let's see, that would be 16 over 60, and then 8 over 30, and then 4 over 15, and we would finally get a solution that is in simplest form. To cross-simplify, we take our original problem, 4/6 times 8 over 20, and we look for ways that we can simplify either within each fraction or diagonally across the fractions. So for example, the 8 and the 6 right here both share a common factor of 2. So if we divide 8 and 6 by 2, we get 4 and we get 3. And then we can do exactly the same thing with 4 over 20. They both share a common factor of 4. So if we divide 4 by 4, we get 1. And 20 by 4, we get 5. Then if we go ahead and do our new problem, which becomes 1/3 times 4/5, we get straight to our simplest form, 4/15. In this example, we actually could have simplified our original fractions. 4/6 in simplest form is 2/3, and 8/20 in simplest form is 2/5. And then when we multiply, we also get to our simplest form of our product. So let's now see if we can figure out why cross-simplification works. And we're going to do a different example here. I'm going to do 2 over 5 times 15 over 16. And both of these fractions here are actually already in their simplest form, so we can't simplify just within each fraction. If we were to do this without any cross simplification, we'd be multiplying 2 times 15, 5 times 16, getting a solution for the numerator, getting a solution for the denominator, and then simplifying from there. If we do cross simplification, what we're doing is we're doing our simplification first before we actually do any multiplying. So in this case, we could actually simplify this direction. We could pull out 5 from each of those because 5 is a common factor. Then we get 1 here and 3 here. And then this direction we can also pull out a 2 because 2 is a common factor of 2 and 16. And we get 1 and we get 8. And it looks like our solution is going to be 1 times 3 over 1 times 8, which is just 3 over 8. And now if we go back to our original problem, 2 over 5 times 15 over 16, we can look a little bit deeper and see what's going on here. So if we were to do this without cross simplification, we would do 2 times 15, and we would do 5 times 16. But the commutative property of multiplication says when we are just multiplying two numbers, like 2 times 15, it doesn't matter what order we do that in. We can do 2 times 15 or we can do 15 times 2. Well, the same goes for the denominator here. We can do 5 times 16 or we can do 16 times 5. So we can rewrite this problem. We can rewrite it as 2 times 15 over 16 times 5 if we want. In this case, we decided the denominator we wanted to flip around. Or we could write it as 15 times 2 over 16 times 5, or we could write it as 15 times 2 over 5 times 16. So any of these 4 problems right here are actually identical to each other. The only thing that I did is I flipped the order of the multiplication in either the numerator or the denominator. And we know that that will give us equivalent products because of the commutative property of multiplication. And now if we look at the last problem that I did, 15 times 2 over 5 times 16, that's actually the one that I did for cross simplification. Because what I really did is I pulled this back apart, and I thought of this as 15 over 5 times 2 over 16. And then within each one of these fractions, 15 over 5, I simplified each new fraction that I have here. 15 over 5 simplifies to 3 over 1. And then 2 over 16 simplifies to 1 over 8. And if we compare what I just did right here to up here, there's 1 over 8, and there's 3 over 1. And then after that, then I can just multiply my new fractions. 3 times 1 is 3, 1 times 8 is 8, and I get my simplest form.